Welcome to AI Frontiers, your weekly deep dive into the cutting edge of artificial intelligence. Today, we're exploring computer vision's latest breakthroughs, insights from 14 cutting-edge papers released on November 6, 2025. Our roadmap for today's session includes setting the stage with the power of computer vision, unpacking core research themes and dominant trends, highlighting pivotal findings and methodological advancements, diving deep into seminal papers, and finally charting the course for future research directions. Computer vision empowers machines to interpret and understand visual information. It encompasses object recognition, scene understanding, and motion analysis. This field is essential for applications like facial recognition, autonomous driving, and medical imaging, effectively bridging the gap between raw visual data and meaningful insights, and driving innovation across numerous AI applications. Our first key research theme is robust tracking and detection. This area focuses on reliable detection and tracking in complex scenarios, addressing challenges posed by dynamic cameras and occlusions. Specialized datasets are being developed for rigorous evaluation, with C-DPO and colleagues showcasing advanced multi-drone pedestrian tracking, pushing boundaries for real-world surveillance and robotics. The second major theme is 3D data processing and generation, focusing on advancements in processing and generating 3D visual data, with applications in manufacturing quality control and asset creation. This includes registration-free methods for unstructured point clouds, overcoming artifacts in TXT-TO-3D generation, and real-time 3D deviation mapping for additive manufacturing. Third, we're seeing progress in human pose and motion understanding. This theme involves integrating human pose and motion for richer insights, grounding vision models with 3D poses for robust action recognition, and nuanced assessment of action quality and performance. Applications span embodied AI, sports analytics, and human-computer interaction, moving beyond mere visual patterns to a deeper understanding of physical dynamics. Key findings across these themes are truly groundbreaking. Dakik and colleagues achieve approximately 90% detection and tracking accuracy in dynamic multi-drone scenarios. Patalano and team enable registration-free 3D monitoring directly from raw point clouds. Dunlop and group introduce personalized image editing via collaborative direct preference optimization, and Shiri and colleagues propose a faster, more accurate capsule network. These advancements promise more robust, efficient, and personalized AI. The methodologies employed are a blend of deep learning and geometric principles. We see novel deep learning architectures, multi-view geometry and fusion for integrating information from multiple sensors, and geometric property extraction for analyzing intrinsic shape characteristics. Diffusion models are being refined for tasks like TEXT-TO-3D generation and medical imaging synthesis, while reinforcement learning and adversarial training enhance robustness and adaptation. Our first paper of the day, a multi-drone multi-view dataset and deep learning framework for pedestrian detection and tracking by C-DPO et al., tackles the problem of tracking pedestrians from moving drones with occlusions. Their solution involves the matrix dataset and a framework featuring real-time calibration and multi-view fusion, enabling robust tracking in complex dynamic environments. This is critical for surveillance, rescue, and autonomous systems, achieving around 90% detection and tracking accuracy. Next, we examine registration-free monitoring of unstructured point cloud data via intrinsic geometrical properties by Maria Francesca Patalano and her team. They address the complex and error-prone registration steps in 3D point cloud analysis by proposing monitoring based on intrinsic geometric properties like Laplacian distance. This enables faster, more reliable quality control in manufacturing, ideal for advanced manufacturing and 3D printing inspection, by eliminating registration steps and reducing false alarms. Our third in-depth paper is Grounding Foundational Visional Models with 3D Human Poses for Robust Action Recognition by Nicholas Baby and colleagues. They tackle the problem of superficial action recognition from RGB data lacking physical understanding by fusing VGEPA2 with 3D human pose data from CoMotion. This results in robust action recognition, especially in occluded scenes, which is essential for embodied AI and human-robot interaction, outperforming baselines in complex and occlusive scenarios. Looking ahead, future directions in computer vision point towards deeper integration of vision with language, audio, and tactile data. We anticipate enhanced controllability, personalization, and ethical considerations for generative AI. There will be a continued focus on developing robust AI systems for physical world interaction, particularly through human pose and action understanding, for embodied agents, and a persistent push for efficient, interpretable, and less computationally demanding models. This presentation was synthesized using AI tools, including Google's Gemini 2.5 Flash Lite model, with text-to-speech synthesis performed by Deepgram. Image generation for slide concepts was assisted by Grok. While human experts reviewed the synthesized content, potential oversights may still exist. All research paper references are provided for further exploration. Don't miss our weekly deep dives into AI research. Subscribe to the AI Frontiers YouTube channel for more insights, engage with our community, and share your thoughts. Hit the notification bell so you never miss an episode. We hope you enjoyed this exploration of computer vision's latest advancements. Links to all discussed papers are in the show notes, including Dakich et al. 2025 on multi-drone tracking, Padalongo et al. 2025 on registration-free 3D monitoring, and Baby et al. 2025 on grounded action recognition. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.